So if that is the case, meaning you have a high degree of certainty in terms of your future interest rate as well as your future payment, then you can apply this formula. So if you look at the formula here, okay, essentially this is basically 2-day payment. So this is your 2 days payment, okay, and then this is your next year payment. That's why Z T plus 1, so next year. But that payment has to be discounted by this. So this I is the interest rate. That's the discount factor for your payment in T plus 1. What about the T plus 2? Well, this is your payment T plus 2. Okay? But it has to be discounted by how much? By this much. Okay? So now you recall why a few minutes ago I tried to explain where is this component coming from by using the example if you want to lend money $1 and then how much you will get 2 years from now. That is essentially the concept of PDV, present discount factor, okay, or present discount value. Now, that is the case if you know exactly what will be the future interest rate and what will be the payment that you will receive every year. So next year you receive this amount, the following year you receive this amount as well. But what about if you don't get that confirmation? So in other words, you're not really sure how much is the payment for next year, as well as you're not sure what will be the interest rate next year, okay? So if that is the case, so if it is unknown, so you replace all these numbers here with expected value. You notice there is an E here. So there is a superscript E. Superscript E reflects the expected value. So for example, this is the amount of payment next year that you expect. You're not sure, but you expect. Okay? Now, the same thing with the interest rate, because you don't know exactly, then you use expected interest rate. That's why you use I and then super E here, okay? And then multiplied by the expected payment for next year, and so on and so forth, okay? Now, let's assume the expected interest rate next year, the following year, and so on. It's all the same. So, in other words, suppose you assume that the monetary conditions will be stable so that there will not be any change in the interest rate. Then you can imagine if this is I, and then the next one is I, and the I, and so forth. Basically, you can replace all with the square here. The next one is to the third power. The next one is to the fourth power. The next one is to the fifth power, and so forth. Okay? So, that is essentially the case, the two different cases here. One case is you know exactly, you can predict or you can make a forecast. And the second case is you don't know. And if you don't know, then you have to use the expected value. Now, there are two ways to treat all these prices and the payment here. One is called the nominal approach. The second one is called the real approach. Okay. Now, in the case of nominal approach, it's, if you suppose today you decide to buy SUN. SUN is Surat Utang Negara, which is government bonds, right? If you want to buy SUN, you tend to use nominal value because I bet what you really want to know is really, first of all, how much is the price and how much you will get in terms of the yield or the, I think in Bahasa Indonesia it's called imbal beli, right? Am I right? If I'm wrong, correct me, okay? But it's essentially the yield. So you want to make the decision to buy or not to buy based on the price as well as on the yield, right? So when you do that, essentially you use the nominal value. So what is the interest rate for the SUN, for example? That's a nominal value. But in some other cases, you really want to know, as I said, remember the example I gave you, rather than lending $1 today and then you calculate what do you receive 2 years from now. In some cases, you want to have a fixed amount of return for 2 years from now. Okay? So, if that is the case, you want to calculate for today, and that is you use the real terms. Okay, so let me repeat. In the case of you want to buy now a financial asset, and then you do some calculation, you use nominal value. But in other cases, you use the real value, especially if you want to make sure you want to receive X amount of return or money this year for, let's say, bonds that has the 10 years maturity, for example. Okay, so you don't care so much about how much you will receive every year. You want to make sure that your return today is a certain amount. Okay, if that is the case, then you use the real term approach. Now, later on, when we talk about macro variables like consumption, investment, and so forth, we will use a lot the second one, the real terms. So in other words, the way we see the relationship between financial market and macro variables, usually we use the real terms. But if you are discussing about the transaction of the financial market, then you are using the nominal value. Okay? Now, this concept also apply to one of the important macroeconomic variables, and that is interest rate. And that's why you have two types of interest rate: nominal interest rate and the real interest rate. Again, depending on what is your activity, if you're doing some financial transaction, you tend to use the nominal interest rate. Okay? But if you are dealing with, some investment, long-term investment, then you tend to use the real interest rate. Okay, so that is just two types of calculations that usually market players are using. Okay, with that kind of knowledge, then we are ready to understand about the bond price and the yield, as well as the stock price and stock return later on. Okay, so let's start with the bonds here. So suppose the price of the 1 year bond, because each bond has maturity, right? So let's talk about 1 year bond. Okay, if the price of 1 year bond is 1,000 rupiah today, okay,